MadLad here, out of character for a quick demo, joining you today in pickle form. Recently, I came across a YouTube channel by a guy named Nicholas Renat, and in one of his videos, he has put together a sample Jupyter notebook to use transfer learning with a pre-trained model to basically come up with a face mask detection model. If you haven't seen it, you should check it out. I'm currently working on a project that requires fast object detection and training a detector, so when I came across Nicholas's videos, I decided to give it a try. It took some time to get my environment set up, but eventually everything worked and the results were decent. Anyway, I didn't much enjoy the process of setting up my environment when all I really wanted was to quickly come up with a simple object detection model. So I decided to take Nicholas's sample code and containerize it. Why containers? In this case, it's because they provide a consistent way to deploy software so that you don't get bit in the ass by software dependencies due to variations from system to system. Plus, once it's containerized, you could add a nice web front end to the whole thing and spawn training containers on demand to get a push button get model kind of product or experience. Now, the container images and the accompanying procedures I've put together give people a way to quickly take some images, label them, train your model, and do a quick inference test with a video file or webcam input. And you can do all that without having to install anything aside from Docker and potentially the NVIDIA Docker runtime if you want to use GPU acceleration. I've developed this on an Ubuntu box, but these images may also work on Windows. If you encounter problems, you should post it in the comments or create an issue on GitHub, and maybe we'll figure it out together. Alright, with that out of the way, let's get started on training our model, and today it just so happens we want to be able to detect balloons. To start, we'll clone the repo with the template workspace and then navigate into the workspace directory. Then we'll copy our unlabeled images into the workspace/images/raw directory. We can then run a Docker container with an instance of the labelImg app in it to label our images. You'll want to first save the save directory and then set the open directory. In both cases, you just need to click the button and then choose the default directory, assuming you use the reference command from the repository README. Some tips for using labelImg is to enable autosave. You can use A and D keys to move forward and back in your image list. W turns on selection mode. Holding down Control and using the mouse wheel will zoom the image. And finally, if you're only labeling a single object, you can set the default label in the upper right so that it will get automatically applied anytime you draw a selection box. Once you're done labeling your images, you'll need to split them up into two sets, one for training and one for testing. You'll need to copy the images and the label data stored in the XML files that was generated by the labelImg app to the workspace/images/train and workspace/images/test directories in a roughly 85-15 or 90-10% split for training to test data. Next, we'll want to update the config YAML file in the workspace directory. We'll need to update the name of the labels to match the names that we've assigned to the labels in the images. We can also change the name of the model and change some training parameters like the number of training steps and the batch size. We can also change the model URL that gets downloaded for transfer learning. Once all the setup work is done, all we have left to do is fire up the container and wait for training to complete. Now that the model is trained, we can test it by running an inference container image using a webcam or a video file as an input. In my case, I trained the model to detect balloons, and to test the model, I'm using a video I shot on my phone of balloons out in my backyard. The model only had about 80 images to train on, so I think it's doing alright. Although it may have learned that a balloon is something brightly colored, as it mistakes an archery target for a balloon. Anyway, that about wraps things up, but before I let you go, I wanted to share some teasers for a few upcoming videos. Here's Johnny! Obviously, this is the best Zoom background for your business meetings.
If you enjoyed this video, go ahead and like, comment, and subscribe. Go on, don't be shy. Do it now, or else, you just might regret it, on the account of missing out on more great content like this. Don't worry, I can await. I'm multi-threaded. You know, running these facilities is not cheap. You should consider becoming a patron of MAD Lab Labs to unlock new research options.